This is chapter 10, number 15. We have a wheel that is on an axle on top of a turntable. The turntable turns counterclockwise, and the wheel is turning from underneath towards us and at the top away from us. The first question they ask is, what's the direction of each wheel? What is specifically, not the direction of each wheel, but the direction of the vector of the angular velocity of each wheel. So, the actual direction of the vectors, in the book they say it's not quite a vector, it's a pseudo-vector. It has to do with mirrors, but we can explain that in class. Essentially, you use the right hand rule. So here's a hand, and the fingers are coiled in the direction of this wheel. So the thumb sticks out, pointing the direction of that vector. So even though the wheel is turning from below and up over, the vector actually is pointing in the negative x direction. So you would say for the angular velocity of the wheel, you could write the left, or negative x direction, or negative I hat. I hat, these I hat, j hat, k hat, those are all specifically directions for vectors. X, y, and z are more placements for coordinates, dots. I, j, and k is specifically for vectors, so lines. The little mark above each of those is what's referred to as a hat. So that's why you call them I hat, j hat, k hat. Okay, now let's look at the second wheel. The turntable in counterclockwise. So if you imagine just turning the hand over like this so it rests on top, you'll notice it's a thumbs up, and that's the direction of the turntable, the velocity, the angular velocity. So you could write up, you could write z direction, oops, directon. There it is, direction, or you could write k hat. Okay. B. Next, what's the overall direction of and the overall angular velocity of this object, these combined wheels? So that's where Pythagoras comes to play. We have 44 radians per second to the left, and up 35.0 radians per second. So here's the sum vector, and if you square both sides and take the square root, add up the square of both sides and take the square root of that, you get 56.2277114 radians per second. Next question is, what's the angle? So the tangent of that angle will be opposite over hypotenuse. I mean opposite over adjacent. So theta equals the inverse tangent of 5 over 44. The units cancel out, which is appropriate because it's in radians. Okay, make sure you're calculating radians, by the way. Oh, actually, no, in degrees, so that's fine. Keep your calculator in degrees. So, this comes out to 38.5 degrees. Your answer would be, keeping in mind the number of significant figures, 56 radians per second at 38. I could say 38.5 degrees above the negative x-axis. Okay, there, it's done. We'll be more in a minute.